Hello students, today we are going to discuss multiplexer. Multiplexer is a combination logic circuit. So it will convert many signal and outputted into one signal. If there are so many signals at the inputs, if you are giving the number of signal at the input, and it will give only one output signal. So generally we have discussed earlier classes how to design multiplexer. The basic principle of multiplexer is what? Suppose in multiplexer, if I'll say the 4:1 multiplexer, so as far as the digital logic is concerned, in case of multiplexer, it may be 4:1, or it may be 8:1, or it may be 16:1 like this. What does it mean? If 4:1 means number of input signal to the MUX, that is 4, and 1 means it will only one output. So 4 input, number of signals to the input to the MUX is 4, and number of output signal only 1. So that means it will convert many into 1. The alternative name of the multiplexer, so it will nothing but many into 1. If it is a 4:1 multiplexer, there will be 4, I0, I1, I2, I3. There are 4 inputs and only one output. Only one output. And another thing is there will be a selector line. Selector line means what? The selector line will be select which one of the input that will be passed to the output. So in case of multiplexer, that will be what? This is your S0 and S1. And in case of 4:1 MUX, there will be what? There is your 4 input and only one output. If this is 4 input means the selector line must be 2. So that means 2 to the power 2. This is nothing but what? If it is a 2 selector line, the input line must be 2 to the power 2. If I will say 8:1 MUX, similarly for 8:1 MUX, for 8:1 MUX, how many number of input line? There must be 8. 1, 2, 3. So I0, I1, I2 up to I7, and must be one output line. And how many number of selector line? There will be 3, because if it is 8, this is your S0, and this is your S1, and this is your S2, and this is your Y. Y is your output. This is your output, and these are the inputs. In case of 8:1 MUX, there must be 8 number of input lines. 1 is output line. How many number of selector line? There will be 3 selector lines. You may give the another name. I have written S0, S1, S2. You may write A, B, C, X, Y, Z, whatever may be. So according to the selector line, the selector line select which one input line, and corresponding in that input line, you will get the output. So if I will say, suppose 0, 1, 0 in a combination logic circuit. So 0, 1, 0, so this is your S0, this is your S1, and this is your S2. If I will say 0, 1, 0, so this logic is high, means S1 is high. If this one is high and S1, 0 is nothing but what? Second line, that is your I2, I0, I1, and this is your I2. Output is nothing but what? I2. Whatever the information transmitted to the third line, that will be given to the output. So this is all about the basic principle of multiplexer. Already I told you in your previous class. So there are, it may be 16:1 MUX. If there are, if it is 16:1 MUX, the number of selector line will be 4, S0, S1, S2, S3, or you may write A, B, C, D, or you may write X, Y, Z, W like this. So according to your naming, so you have to prepare a truth table, and according that you have to develop the logic according to that logic, and you can implement the and find out the logic equation. On the base of logic equation, and your circuit can be executing. So though this is the basic principle of multiplexer, how you design the combination logic circuit like MUX, demux, encoder, decoder, adder, subtractor, all these things. As far as design is concerned, so this is a straightforward question. Simply design 4:1 MUX, 8:1 MUX, 16:1 MUX, like that. So if 8:1 MUX, the number of input line is your 8, and output is 1, and selector line will be 3. If it is 16:1 MUX, the number of input line is 16. One output line, there are 4 selector line. This is all about the basic principle of multiplexer. So question is, if you have to ask the design, suppose if I will tell you, and a very important question as far as university examination is concerned. So if the question will ask design a 4:1 MUX, 4:1 MUX using design 4:1 MUX, if the following minterms given. What do you understand? Following minterms given means, suppose f of a, b, c equal to sigma 0, 1, 5 and 7. This is a question. This type of question frequently asked in your university examinations. So you have been asked to find out or design a 4:1 MUX if the following minterms have been given. So you have to, first of all, what we are going to develop a logic circuit so that the question mentioned, that is your minterms, how many number of minterms given. There are 4 minterms given. Using these 4 minterms, you have to develop the logic, prepare a truth table, and secondly, you have to develop the logic equation or Boolean equation, then minimize the Boolean equation, then finally you have to design the circuits, that is your 4:1 MUX. If it's 0, 1, 5, 7, clearly it mentioned that how many number of variables. There are 3 variables, A, B, C, and first of all, step 1 is first prepare a truth table, that is your what? If since there are 3 variables is given, A, B, C, so truth table like this, that is your what? In case of digital electronics, 0, 0, 0, 2, like this, 1, 2, 3, and this is your 4, and this is your 5, 6, and 7. First of all, prepare a truth table. Then, what we have to do? First of all, there are how many number of minterms are given? 4 minterms are given. So, since there are 3 variables A, B, C, this is your A, B, C, and like this, here decimal value I can write here 0, 0, 0, that is your 0, this is 1, this is 2, 3, 4, 5, and 6, and 7. So 0, 0, 0 equivalent decimal value is your 0, 0, 0, 1 decimal value 1, 2, 3, 4, 5, 6, 7, like this. Here 0, 1, 5, 7, in that position minterms are given. That means what? So here 0, the minterm is present here, and 1, the minterm is present here, and 5, minterm is present here, and 7, and minterms are present here. And except these 4 minterms, how many number of minterms? Since there are 3 variables, there are 8 number of minterms. In 8 number of minterms, what is minterm? Already I told you, minterms is nothing but your product terms. So represents either 1 or 0. If the minterms are present, that means you have to sure that in that position the binary 1 is present, and in other place that will be 0, like this. Okay. So you know that in that position 0, 1, 5, 0, 1, 5, 7, the minterms are present. This is the first step, prepare a truth table. Then the question does not mention out of 3 variables, which variable taken as the input to the MUX. So since this is a 4:1 MUX, we have to design 4:1 MUX, that is what? 4:1. In 4:1 MUX, there must be 2 selector line and 4 input lines. In 4:1 MUX, there will be what? 4 input line, one output line and two selector line. In these two selector line, out of these three variable, we have to select two variable as your selector line and one variable to the input to the MUX. So here, in case of to design 8:1 MUX and the four minterms are present 0, 1, 5, 7, and this is a table that is what? That is your, I can say this is your A bar and this is your A, like 0, 1, 2, 3, 7. So this is very, very important as far as design of multiplexer is concerned. This table is important. First of all, you understand why I am writing here A bar A, why I am writing 0, 1, 2, 3, 4, 5, 6, 7. If the question, if there are three variables and question asks design a 4:1 MUX, there must be 4 input line and 1 output line. So out of 3 variable, I am taking A first MSB. This is your MSB, as this is your what? Input to the MUX. This is your what? Input to the MUX. Input to the multiplexer. That means these 4 input lines represent either A bar or 1. I am writing here, I will tell you. So this is a 0, 1. You can write if A variable is given to the input to the MUX, remaining 2 variable BC can be selected as your selector line. Here I can write here what? B bar C bar, B bar C, here BC, BC bar and BC. Why I am writing here? Look at this here, whether your table is satisfied or not. A bar, B bar, C bar, 0 or not? Here 0 for bar, A bar, B bar, C bar. That is 0 or not? 0 or not? Similarly, I can write here, you can check it. A bar, B bar, C. Here A bar, B bar, C. The value is 1 or not? Look at this, 0 for bar, A bar, B bar, C. Min term is nothing but product term. A bar into B bar into C. What? The value is 1. The value is 1. You can check it here. This one. A bar, B, C. Look at this here. This is your A bar, B into C. 3 or not? Any value. Here, you can check it this value. Here A, B, C bar. Here, look at this here. A, B, C bar. 6 or not? So this is your part implementation table. If there are 3 variables and 4:1 MUX, you have to remember this type of table you have to form. That means what? 4:1 MUX like this. After preparing this table, first of all identify where is your min terms here. In this question 0, 1, 5, 7, there are 4 min terms and encircle it. That is your 0, then 1. This is your 0 and this is your 1. Then what? 5 and then 7. Okay. Since there are 4 min terms, you have to encircle it. I mark it as a red circles. So then this is your what? I can write here. This is your I0. This value is your nothing but I1. This is nothing but your I2, and this is nothing but your I3. Here first I0, only one encircle it, 0. The corresponding value is your A bar. So I am writing here that is your A bar. Similarly, if there are corresponding 2 values, encircle it. A bar plus A, the value will be 1. In Boolean algebra, x plus x bar is 1. A bar plus A, that is 1. And this is nothing but what? That is 1. And in I2, none of the values encircle it. So that's why that will be 0. Similarly, here there is 1 value here, encircle it. This is nothing but what? That is your A. So that's why I0, this is your I0, this is your I1, this is your I2, and this is your what? I3. In I0, the value is your what? A bar. I0, that is A bar. That's why I0 A bar. That is what? This is your A and complement A bar. This is nothing but A bar. So I0 is nothing but A bar. I1, that is 1. So 1 is nothing but what? You can write that is your plus VCC. Plus VCC is your what? Plus VCC, that is your 5 volt, or you mean you can write that is your 1 plus VCC, or it is equal to 1. Then I2, that is 0. This is your I0. This is your I0. Then I1. This is your I2. I2 is nothing but here grounded here. This is your I2. Okay. And I3, that is A. I3 you can write directly. You can convert it like this. This is your A. Okay. This is your I1. I2 is grounded here. And this is your I3. And this is nothing but your what? That is your Y. Y is your what? That is your output. Okay. In this two selector line, you can write this your A, and the two selector line you can write this your B, and this selector line that is your C. This is your final design of multiplexer, and out of these three variable A is input to the MUX, and remaining two variable as given to the can be selected as a selector line and only one output line. In this way, you can design 4:1 MUX. If there are certain min terms are given, you have been asked to design multiplexer, then in this way you can design it. One common thing is that first of all, prepare a truth table, that is your logic table. Since there are three variables A, B, C, and identify where is your min terms 0, 1, 5, 7. You can write that is your here 0, 1, 5, and 7. There are four min terms are present, and then this table is very important. First of all, you prepare this type table. If the A, B, C, there are three variables, and A, MSB as input to the MUX, this is A bar A, you can directly write down in row wise 0, 1, 2, 3, 4, 5, 6, 7. After writing this, you have to check whether your table is right or wrong. Any value you select it and check it whether your table is properly designed or not. If this is a 6, you can check it A, B, C bar, that is your A, B, C bar, that is your 6. And another, suppose you will check 2, A bar, B, C bar, that is your A bar, B, C bar. That means you have to confirm that what the way you have prepared the truth table, that is right. And then where is your min terms? First of all, you encircle it. And if consecutive to encircle, then this will be 1, because A bar plus A is 1. If you can find out the value of I0, I1, I2, and I3, since it is a 4:1 MUX, I0, I1, I2, I3. What is the value of I0? What is the value of I1? What is the value of I2? And what is the value of I3? After processing all the things, then finally, this is the last step to design 4:1 MUX. This is your 4:1 and your I0, I1, I2, I3, because this is your 4 input line, 1 output line, and if since it is your 4, this is your 2, because 2 to the power 2, that is 4 lines. So BC, that naming as after A as input to the MUX, remaining two variable have selected as selector line BC. So in this way, we can design the multiplexer. Thank you, students. And next class we will do more and more number of problems and different variety. We will go through for varieties of multiplexer problem, how we will solve it. Thank you.